So basically we can do the same thing with any trig function, right? We can use that same model that we used with cosine earlier, and we can extrapolate that to sine, to cosine, tangent, cotangent, secant, cosecant. And basically all it is just the derivatives that we already know, right? With the g of x function on the inside, and then we're multiplying by the derivative of the g of x function, or the inner function, on the outside. Okay. This right here is Leibniz notation, so we're not going to get too much into that, but it's basically the same thing. It's just the u function is the inner function, so we just take the derivative of that. So it's just derivative of sine of u is cosine u, but then we multiply by the derivative of u with respect to x. So so u would be u as a function of x, and this is just basically the derivative of that. So it's basically the same as this, just different notation, different way to write it, or say the same thing. All right, so that's a table that you can have in your notes, and that may help you out down the road. So then we can do some different things, or we can use some other properties or other rules. And so here we're using the product rule in conjunction with the chain rule. Okay, so here we have a product of two functions. We have this function and this function. So let's call this f of x and g of x. So remember that the derivative of a product is equal to f prime g plus g prime f. Okay, and so when I take the derivative of this, I'm going to use the chain rule. So the derivative of f prime, is going to be 5, and then I'm going to put the inner function back inside, and then I'm going to take away 1 from the exponent. So I'm just using the power rule there, right? Multiply by 5 in the front, take away 1 from the exponent. Similar, then I'm going to put the regular g next, so that's just going to be this here. So it's going to be 3x minus 2 to the 7th power. All right, then we're going to add here, and then we want to take now the derivative of the g function, right? So that's going to be 7 times the quantity of 3x minus 2, so I just put that function right back inside, to the 6th power, right? And I just realized I missed something earlier. And so what I forgot to do here is multiply by the derivative of the inner function, right? So the derivative of this 2x plus 1 is just 2. So I'm just going to multiply by 2 in the front here. Okay, and then I'm going to do the same thing here. The derivative of this inner function would be 3, so I'll just multiply by 3 in front. I could multiply by 3 in back as well, it's okay. But since I didn't have enough space here, I just put it in the front, and I'll do the same thing here. All right, and then now I'm just going to put the regular f function, or the original f function. All right, and that's basically it. So we could expand this. There's not a whole lot of use in that. Like it's going to be pretty tedious. So this is fine to leave it like this. If you want to just simplify these, you could make this 10, make this 21. But yeah, it's fine to just leave it like it is here. Okay, so you can just leave that, and that's our final answer. So we use a product rule in conjunction with the chain rule here.